Here is an example. We need to compute the inverse transform of this one. Use convolution. So we can, of course, use a partial fraction decomposition. This would be easier. Partial fraction decomposition. Also easy. But let's use convolution. So the theorem is that Laplace transform of ft convolution with gt, the convolution of ft and gt is the Laplace transform of f star g is Laplace transform of f times Laplace transform of g. So this means that if we do the inverse transform, you would get ft star gt, which is the convolution of f and g, is the inverse transform of these two functions, say big F and big G. Big Fs times big Gs, where big F equal to Laplace transform of small f, big G Laplace transform of small g. In our example, we will use this one. So inverse transform of this function is will be f of s times g of s. So f of s I will choose to be 1 over s. G of s I choose to be 1 over s squared plus 1 equal to this one equal to Laplace transform 1 over s times 1 over s squared plus 1. So 1 over s is just the transform of 1, the function ft equal to 1, and 1 over s squared plus 1 squared is the transform of function psi of t. So this is function small f of t, and this is function small g of t. And you can write as inverse transform of the Laplace transform of 1 times Laplace transform psi of t by the theorems, convolution theorems. There you know that this is the function ft star gt, so the convolution of 1 and psi of t. So recall the definition of convolution. Ft star gt is commutative, so gt star ft equal to 0t f tau g t minus tau d tau. In our case, 0 to t, f tau is 1, gt minus tau is psi t minus tau d tau. 0 to t psi t minus tau d tau. So this is minus cosine t minus tau divided by minus 1. Tau from 0 to t, cosine from 0 to t, so cosine t minus t minus cosine t minus 0. So cosine 0 equal to 1 minus cosine t. So that is the answer for the inverse transform of this function using convolution.